We will go ahead and get started here. Thank you everyone for joining us for Zero Energy Homes, updates and cost-effective approaches. Before we begin, we would like to take a moment to thank our partners at Better Built Northwest for generously supporting this training. Here's a screenshot of the Better Built Northwest website, where you can find a variety of trainings, tools, and resources to support both code and above code building, as well as directories that will help you search by zip code to find an energy rater, utility incentive program, certification program, and other professionals in your local area. You won't want to miss the upcoming 45L resource page. We encourage you to sign up for the Better Built Northwest newsletter to be notified of the launch of this and other resources. So I'm going to go ahead and take this moment to hand it over to Mark, who is our presenter this morning. Thank you for being here, Mark.
Awesome. Thank you so much, Aubrey. My name is Mark Rager. I'm the Certifications Senior Manager located here in Portland, Oregon. My job is basically to help builders, developers, architects design and construct to the standards of our Earth Advantage Green Building Certification, as well as other certifications, energy efficiency programs, and rating systems. I've been a HERS and Passive House rater for over 10 years and have worked on projects from large production homes to high efficiency, zero energy, and passive houses. So I'm really excited to be here today and present this webinar to you guys. Just a little note, we're going to be concentrated mostly or all on single family homes. So if you're looking for maybe existing homes or multifamily or something like that, let us know. And maybe that's something we could develop in the future. But for today, for this webinar, we're going to be concentrated on single family. So zero energy homes, what is the perception out there? And maybe the perception is that, a zero energy home is lent only for these, custom built multi-million state of the art houses out there that you'd see on some hill overlooking this land. As you can see this photo right here of this beautiful house that Hammer and Hand made that we've certified many years ago, and that is still true, and it was true at some point in time. But I think you'd be surprised to find out that most of the zero energy homes that we see, or zero energy ready, definitely zero energy ready homes that we see out there, are going to be some, standard looking construction homes of new construction homes. This is a really great example of our friends over there at Green Canopy built this infill duplex house here that's certified platinum and zero energy ready and infill here in Portland, Oregon. And you can see zero energy homes can kind of fit into these neighborhoods. And obviously this one's a little more modern looking, but most, new construction is these days. But it is a pretty standard looking, house that you can find in a lot of different neighborhoods. When we're talking about zero energy ready homes, this is a really great example of how you can build and zero energy ready homes in a production setting. This is a really, nice looking, but, good looking production home that you can see in a lot of different subdivisions out there. On our, partners at Noise Development build 100% all certified zero energy ready homes in a production sense. And you can see it kind of looks like just a standard home out here that's certified to zero energy and making those steps. And then all we have to do is put on our solar panels, and now we're certified zero energy out here. As you can kind of see in this photo, all those houses out there, all certified zero energy ready. And this particular house right here was a model home, and they went forward and put on the solar panels to make it zero energy. But these things can be done on a regular style construction house in a production setting. Another really good example here of a standard entry-level new construction is a community out in Bend, Oregon, that Habitat for Humanity built that are all certified zero energy. Really simple construction out there and affordable and can be zero energy as well. So, how do we define it? What is a zero energy, building? Well, we can take a stab at it. I would define a zero energy building as, a building that produces as much energy as it consumes over the course of a year. These buildings can achieve zero energy first through good design, high levels of energy efficiency, good building science practices, and then at the end, add on that solar system and that renewable power generation. That's a pretty good, example and a pretty good definition, I think. But maybe there's other things to think about. Is it annually? Is it monthly? Is it daily? Is it hourly? Obviously, some months you might be positive energy, might be producing way more than you're consuming. Other months you might be right on the mark, and some months you might be low. So going to that annual kind of thought process kind of evens that out and distributes that out through the year. And so we can kind of see that. But maybe you are thinking of like, am I zero energy right now? Maybe not, depending on what's going on out there. We want to talk about site versus source. We were talking about, is the zero energy on this lot? Is this particular building producing as much as it's consuming? Or maybe you want to look at it through maybe a lens of a subdivision, or maybe you have a set of infill row houses you want to be zero energy, where some roofs can't hold as much solar for that particular unit, or some streets or some orientations aren't working in a production setting, and you need to make up some energy there, maybe through more panels on certain houses, or maybe we have a solar array somewhere out there in some common land, or maybe we have some parking structures that we're putting solar panels on in order to get the whole subdivision together and be able to be zero energy. Maybe take a step, further in that, and we're looking at, source energy, energy loss through transition mines. Maybe you have some gas and fuel mixes that you're still using, and you want to make up, for that all the way at the source, at your utility there or your state grid. That's a really great way to kind of take that step further from site energy, but also, making up all of our source energy out there. Maybe we even go a step from that, and we're looking at zero carbon. So we're looking at source energy plus the embodied carbon of the materials, the energy it takes to transport, or the energy it takes to manufacture or create these materials. And we're going even farther and farther back to try to make up for all that energy and all that carbon use, and looking at it through more of a decarbonization lens. We're hearing and seeing more and more of that out there in the market, and I think it's a really, really great forward thinking, a good step out there. And then, how are we evaluating this? Are we looking at it through some predicted energy models? Are we looking at the estimated production from a solar bid versus the estimated consumption out there that's done from an energy model while that's being constructed, or right after it's being constructed, and or labeling it zero energy based off of those estimations? Or are we going a step further from that, and are we looking at the actual data out there? What did this system actually produce in a year? What did this house actually consume in a year? And then we can decide from there whether this building is actually zero energy or not. It's something worth thinking about, and there's a lot of different models out there of those kind of thought processes. So doing what a zero energy does, definition, we have some great definitions there, but what's a zero energy ready building? What does that mean if we don't have actual production going on? How are we defining zero energy ready? And there's a lot of different programs out there that can define this in different ways. One that's definitely gaining a lot of traction is the Department of Energy's Zero Energy Ready Home certification. They're defining this as a zero energy ready home. It's a high performance home that is so energy efficient that a renewable energy system could offset most or all of the home's annual energy use. Not a bad idea there. Not a bad definition at all. This program out here, you need to be working with a third-party rater. You need to comply with a few different prerequisite programs like Energy Star and Indoor Air Plus. You need to be following their Solar Ready checklist. which is, you know, required in some locations and maybe not required in some other locations, depending on, you know, the solar output or what we can get there for solar in that climate or in that specific zone. And, you know, at the end of the day, this is an energy efficiency in an ERI driven program more than it's a production meets consumption program. So what they're basically saying is, you know, if we hit these metrics, you know, we lower our consumption and meet these energy metrics to, you know, this certain degree that we've laid out. And then we think we can reasonably put on a solar system that will meet those energy demands and meet that consumption. So that's definitely one way to look at it, and definitely a great way to get that product out there nationally. And also, you know, something to look at is, and we'll talk about this a little bit more down the road in this webinar, but there's $5,000 45L federal tax credits available for this program. You know, that's a lot of money, something to look at in a way to, you know, get out there and build some certified zero energy ready homes. But we'll talk about that a little bit more in the future. You know, here at Earth Advantage, we kind of take a little bit of a different approach of what we're going to call zero energy ready home. So our zero energy ready home, you must participate in our full green building certification program. So you got to meet one of the levels of our certification program, which is silver, gold, or platinum. And we're not looking at just energy efficiency. We want to look at, you know, water use, land use, indoor air health, different things like materials and durability and all these different pillars we want to look at as a whole building out there. So we need to participate in that full program. And then also be meeting our solar ready measure, which we'll go over a little bit down the road here. But the home has to be read up and set for solar. And then you also, at the end of that, you need to bring us a solar proposal. So you need to go out to a solar contractor, get a solar proposal for that particular building and model, show where those, you know, solar panels can go, and show us what that estimated production is. And as long as that estimated solar production can meet our estimated consumption from our energy modeling, we're able to certify that building zero energy ready. And it's also a really, really great lead for solar contractors out there for your homeowners for whenever they want to move forward with putting solar on there. So whether they put solar on there later or you go ahead as a contractor and do it immediately, we can certify that zero energy once those panels get on there and it is to the system that we have those bids on, and that production is going to meet that consumption. So that is our program out there, a little bit different than the DOE program. And for all you Washingtonians out there, our friends at Built Green, they have their net zero energy certification, and something you might look at if that's in your territory. They're looking at kind of the same type of system where that production needs to meet that consumption. You also have to participate in their full Built Green certification at any star level. And they take it actually a little step further, where they're, requiring that receive a waiver so that energy data from utility can be shared with the program. I think that's really interesting. I don't believe that they decertify, if at the end of the year, maybe that, production didn't meet that consumption, but I think it's a really good and interesting step forward, possibly of kind to validating, some of these predictive modeling that's going on and seeing how that program works. Another kind of national program and a really, challenging program out there. It's right there in the name, the Living Building Challenging Zero Energy Program is another, production needs to meet consumption type of zero energy certification. But they go even a step farther, where they're not going to certify your home until they have all that utility data and all that solar production data down the road a year from now. And if it does meet that, if the actual production meets the actual consumption, then you can get your certification on that building. So that's another step out there. I really, tip my hat to those guys for putting that together. Another great national program out there is PHIUS, is the Passive House Institute of US. This is a really robust energy efficiency certification that's really concentrating on, lowering that consumption, lowering our energy loads out there, there's really going to set you up for being zero energy, with the least amount of solar as you need to put on it. I think it is absolutely an excellent pathway to zero, and we're going to be seeing more and more of these type of homes going on into the future. And they also have a zero carbon certification that's out there, like we talked about earlier, of taking those extra steps, and looking at it through kind of a carbon lens, and not just kind of a site production thing. So really great program out there that I work on quite a bit. So, what's the value? Why do we want to do zero energy or zero energy ready homes? Well, number one is comfort. Sure, can there be an uncomfortable zero energy house out there? Absolutely. You can throw solar panels on anything, and make it zero energy. But if you're following the steps that we're going to lay out here pretty soon in this webinar, it's going to, with good building science practices, it's going to reduce that energy use, make more comfortable buildings for your occupants out there by following these type of principles that we'll lay out. Health, this could be the health, indoor air quality health of your occupants, and health of the environment around us. We start introduce filtered ventilation. We start, taking, bad materials, toxins out of the house. We're going to have better indoor air quality, moisture control, definitely a big part of that. And then we also want to look at, what are we doing for the environment around us? 40% of all the US carbon emissions come from buildings. Reducing our energy consumption and fueling it with renewable resources is going to help reduce the effects of that climate change. We're moving forward with codes and goals that we want to meet out there. Getting zero energy ready homes is a really great step. Getting zero energy homes is a step that we want to get to eventually. Resiliency. Obviously, there's a lot of talk about resiliency these days. We're seeing a lot of big storms out there, power outages. Getting yourself a good, tight energy efficiency building, and then also having that renewable power. Maybe we're putting storage on that, solar storage, and making our houses more resilient for ourselves, longer lasting. Durability, absolutely. When we're doing building science practices and energy efficiency and watching our moisture control, we're making longer lasted, more durable homes with that. And then, financial, we want to protect ourselves from these rising energy costs. It's only getting more and more expensive out there. And so when we go zero energy, we are really protecting ourselves from those rising costs. And all these systems have their simple payback. They will pay for themselves down the road. And as these, energy costs rise, that simple pay gap gets smaller and smaller. So there's a great financial reason to move into these types of homes, with lowering operating costs and protecting on rising energy costs. So how do we do it? Our friends at the Zero Coalition, put together this really great 7 steps to cost-effective steps to zero energy buildings or zero energy ready buildings, that we're going to follow and use kind of as a jumping off point for this webinar. And that first step is going to be, set your project energy goals early. Maybe arguably the most important step out there is start doing this at design. Make a decision, get together with your project team, and lay out the goals that you want to have for this particular project. And that's going to be a really great way to kind of plan and design and reduce costs and issues that are going to be down the road with trying to make it happen, mid-construction. Get together with your project team, get together with an energy efficiency consultant, get some energy modeling going, get a early design assistance or a IDP or integrated design process, EcoShred, whatever you want to call it. But start doing this early in the design phase, and get those goals in set, get those people in set, and then once we start designing, we're doing that with these goals in mind out there. One of the first things we kind of want to really look at is optimizing our building shape and orientation. Our low surface to volume ratios and simplified design is going to ease construction costs. It's going to make the house much more energy efficient. It's going to be a lot cheaper to construct. And, that is a really, really great, first step. We're looking at design is looking at that low surface to volume ratios. We want to be looking at how we orientate our house. Obviously, we want that east-west orientation, good southern exposure, great roof lines and pitches, simple designs. And so we can really get planned for our solar in the future. We want to make sure our penetrations are in the right spot. And so we're not having any issues putting our solar panels on when it's time to come to that. We want to look at our windows, where are we where are we placing them? How are we shading them? Maybe in our southern exposure, we want, as much sun to come in the wintertime, and reduce those heating loads. And then we want that sun to be out of there in the summertime with some shading to reduce those cooling loads. We want to look at maybe our solar heat gain coefficients and where we're putting those in certain windows and certain orientations. All these things can be built and thought about in our design phase and making sure that we're getting those into plans, and start utilizing energy modeling as soon as you can while you're designing. Ideally, maybe you have someone on staff that's a WFI modeler or a certified passive house consultant, and you can start doing it through that. But if you don't, start looking at working with PERS Rater and Energy Rater right away. Get some energy modeling done as you're designing. Like, what about this wall system versus that wall system? And we're doing a cost benefit analysis on there. A lot of value engineering going on. What about this mechanical system, ducted versus ductless, or this different HSPF versus this HSPF? What if we do this or that? Start working with this value engineering and start working with all your cost benefit analysis out there of these different things and these different assemblies that might work for your building or for your clients out there. The earlier you start doing this, the better your decision making be made, and the more money you can save down the road, once you start doing this value engineering. Not only that, these HERS raters, they're building science experts. They're hammered and live, eat, and breathe this stuff every single day. And so when we're talking in the design phase and making these kind of decisions, we can kind of, think about, how is this going to affect this other thing in the house? How does this work as a house, as a system, and kind of can bring some of these building science concepts, into your practice and into your construction. If we want to work with any of the certifications out there we kind of talked about earlier, and those aren't any of them, those are just some of them in our market and some national ones. Maybe there's some different ones out there in your area, wherever you're at. But normally when we're working with certifications or programs or energy ratings, those are going to be kind of shepherded through your HERS rater out there. And so they're going to be able to let you know what all the requirements are right away and get ahead of that and make sure we're planning for all that, getting it into our plans. And so we can execute correctly when we're actually doing out there and we're constructing. They're also going to know about all the utility incentives and federal tax credits that are sitting out there and help you leverage all those to help, alleviate some of the costs of this construction and be able to get all those and, squeeze them as best as you can, and make sure that we get those into your hands and help you build these, high efficiency buildings more effectively and more cost effectively. And maybe I'm tooting my own horn here a little bit as a HERS rater, a longtime rater. I think it's really, really important, but the experience these people are going to come. So they're working with all different types of builders, right? And all different types of building types. And so they're out there, boots on the ground, working with different people, seeing what works, seeing what doesn't work. And they can kind of bring kind of that institutional knowledge to your project, from all the different types of contractors and architects and building types and systems, can kind of bring that in and give you some good consulting and good advice of what is working and what's not working based off of that. All right, next one, design high performance envelope. Yeah, this is really, really huge. This is the shell of your building. This is the thing that's going to last. So you want to create a really nice high performance shell. And when we're talking about that, we want to talk about our control layers, right? Stiebrick would say something about that, about the perfect wall, and it's absolutely true. And we want to talk about our bulk water control layer. We want to have keeping all of our bulk water off of our assemblies. So that's gonna be done through a really nice tightened up WRB. Maybe we have rain screens and then ventilation going there. Maybe we have some extended eaves happening to keep all that rainwater and bulk water off of our assemblies there. Always the number one moisture control, number one important thing in a building. Next, we're talking about our air barrier. I'm telling you right now, this is going to be the most cost-effective, low-hanging fruit out there to reduce that energy load, reduce that consumption, and create more comfortable buildings. So I highly suggest you look at it and invest in your air sealing and your air barrier techniques. And there's a couple of different ways we can go about this. Maybe you're still using a primary air barrier strategy where that drywall is going to be your air barrier, and you're going with some, air sealing techniques, with rattle can foam and caulking and seal, and, using a really good checklist, and you can have really good success with that. I have seen that. I have seen very tight houses being done with a rattle can foam and a really good checklist if it's executed really well. But maybe you go into a different strategy and you get to a product like Aero Barrier. I can't speak highly enough of that product. It works. It is very consistent. And, shout out to all the people out there in Air Barrier doing that work. Seems like a cheat code sometimes to get those, low ACHs in your house when we're looking at drywalls or primary air barrier. But maybe we want to take a next step, from that, and we want to go to more of an integrated air barrier design. Maybe we're pushing an air barrier, out to our sheathing, and we're using a product like our WRB, or maybe it's an Intello product, or a Siga MyVest or something like that, and we're working on our exterior air barriers, and we're bringing that up, and maybe we're bringing that all the way to the roof line and creating a nice air barrier all the way, continuous air barrier on the outside. Or maybe we're bringing a product like Intello or MyVest, underneath the roof trusses, and we're doing an air barrier right there. And that's a really good way to be able to look at our air barrier really early on. And not just that, but be testing it. We can do preliminary blower doors. We can really make sure this thing is buttoned up before we cover it with anything. And that maybe that's a strategy that works for you and is good for your clients and good for your project. But after that, we want to get in our thermal barrier. That's our next control layer in contact with our air barrier. And there's a lot of different ways you can do this, but maybe it is just a simple 2x6 wall with intermediate framing or advanced framing and some blown in fiberglass, and a very simple wall system that might work for you for a zero energy ready home. It might be a very cost effective solution, but maybe you want to take the next step further and you're looking at some exterior insulation to reduce any thermal bridging that you have in there. Maybe you're looking at a staggered stud or a 2x8 wall, a thermal break shear, what they call a TBS wall system, where our rigid insulation is in between our sheathing and our studs. There's a lot of different wall systems out there that have all their different benefits and all their different cost systems. But this is where value engineering is going to really come in, and we want to look at those cost benefits and make sure we're doing what is right for your building. But don't think, to do a zero energy building, that this has to be some super insulated 12-inch robust with Larson trusses out there. That's not the case. We can do zero energy buildings, and we can do zero energy ready buildings with more, simple construction out there, as long as it's executed really well. High R values, low U values, right? You want good high R values in our walls and low U values in our windows. Kind of means the same thing, because the U value is just the inverse of an R value. But our windows, we want to look at, maybe we can do it with some 0.27 windows, or maybe we're looking at some triple panes if that's a project you want to look at. Obviously a lot more expensive to go that way. Maybe you want to go to a product like a thin triple pane window. I really did an interesting study with Habitat out there in Bend, from moving from exterior insulation to a thin triple pane. And, what is that cost benefit? Is the performance there? Is, the cost difference? And so we can kind of, through that modeling and through that value engineering, start looking at all these different assemblies and figure out what is good for your particular project and your building goals out there. Next step is specify, high efficiency mechanical systems. Yeah, absolutely. We want to put in, install high efficiency heat pumps. That could be a ducted system, or maybe that's a ducted system, but we want to make sure that we are designing the system and sizing it correctly to that specific house. You need to go out there, and whether it's your HVAC contractor or maybe you're using a third party designer, here at Earth Advantage, we do third party HVAC design all the time. And we want to make sure that we are designing and doing our manual JDS calculations for your particular house with your particular envelope specs in that. So we can kind of make sure we're not oversizing or undersizing, but right sizing this equipment. And then we want to make sure we're installing it. If you're using a ducted system, bring those ducts inside that conditioned space. And when I say conditioned space, I mean within that pressure boundary, not necessarily just buried deep. You want them inside that pressure boundary in that conditioned space. You can kind of see a really good example here on the slide of a way to execute that. And so, yeah, really important, bring them inside, get these things sealed really good, lower that leakage, install them as they were designed. We want to make sure, our design flows in our rooms are our actual flows. And then we want to be testing to make sure that happens. So commissioning our systems is a really important part of this process. So make sure we are design, installing, and then commissioning our systems correctly. We have a really great webinar on our website. I think there's a link toward added towards the end of this webinar of our heat pump mastery. It's a 3-part webinar, I think, design, install, and commissioning. And so make sure you go check that out and be following those steps. Next step is that we want to introduce our balanced ventilation with heat recovery. Balanced ventilation is now code in Oregon. Heat recovery isn't quite there, but I highly suggest that. I know this can be, we're looking at some costs here, but there's some different steps that you could do. Maybe your building lends it to you can use just a spot ERV or something, like bring valve ventilation in with a little bit of heat recovery in a low cost scenario. Maybe you're building an ADU or a really small building and that works. Or maybe you take the next step up where you're, bringing an HRV in, but maybe you're just doing a couple supplies and a couple returns and lowering the cost of that, but still getting some balanced ventilation and heat recovery in there. Or maybe you're going to the full Cadillac system, a full distribution, and getting all our supplies in our bedrooms and our returns and our exhausts in our bathrooms or hallways, and doing this full distributed system, which is incredible and great. And I think we're seeing more and more of that. But what's going to work for your project? Do some energy modeling, do some cost benefit analysis. But I highly suggest we move to heat recovery on that when we're working with these type of buildings. Installing a heat pump water heater. These things are incredibly efficient. A regular standard electric tank is going to be 95% efficient. These things are 350% efficient and becoming more cost effective. So look at that product. We want to, reduce our loads and, not just, reduce the energy use of, heating up the water, but we want to consider our, efficient hot water distribution, which is going to be a requirement in some programs out there of how we distribute the water around the house. So definitely some things to think about there. Next, select efficient appliances and lighting, kind of a no-brainer and very simple. LED lighting out there is cheap, it's effective, and it's everywhere. So putting in LED lightings everywhere, but maybe we want to, looking at daylight lighting modeling, and, maybe we don't need as many indoor lights if we have good daylighting. Maybe we want to look at some smart controls, motion sensors, occupancy sensors. We're looking at, dimmer switches or something like that that can, be reducing the energy of that building. Install all of our Energy Star appliances. It's going to be a requirement if you're working in that DOE program or here Earth Advantage or Energy Star or some of these other programs are requiring all Energy Star appliances. They're everywhere. Make sure we're putting those in. And so those are kind of no-brainer, really simple step to reduce some energy there. And next, kind of when we hit all these steps, we got together a plan and we designed our house nice and we orientated it good and we built a really nice high performance shell and executed that well, and it's really tight, and we put in high efficiency equipment and it's designed well and it's installed well, and we got our lighting and our appliances, and we got all these pieces of these puzzles kind of built up to put in. And then we can start looking at a renewable system, right? We want to reduce the consumption of that house, reduce the consumption of that load so we can put a smaller system on, right? Solar's, it's getting cheaper, but it's still pretty expensive. So the smaller the system moving on, the better. So at the end, we want to reduce that consumption, and then we can size that solar system to that and install that. But, maybe also we're stopping a little bit there. We're not going full zero energy, and we're going for just zero energy ready. How do we get this thing solar ready? Here's a really, really great example, and we've taken this from our, our good partners there at Energy Trust of Oregon and their EPS program. We've adopted it at Earth Advantage as our solar ready measure, and we need to make sure we're putting these into their houses for them to be zero energy ready. So we need to have that space in the breaker, have that ready for future solar on there. We need to have, space on the walls for future inverters. We want to make sure we have a 3/4 inch, or maybe even a 1 inch, depending on the size of your house, non-flexible metal conduit, going from our J box, at the wall near that breaker all the way to the J box up there, at the roof, and making sure, our future solar contractors have, conduit to be able to run their lines down and hook that up and hook up those inverters. We want to make sure that obviously we're orientating and creating, really good, simple roof designs that allow themselves for solar on there. But we also want to make sure that we are watching where our penetrations are going through our roof, whether it be roof fence or plumbing penetrations, flues, different things like that. That we're not putting them into the spot where we want to have solar. So really, really important. I can't stress this enough. Get it into the plans, put out where those solar panels are going to be and get those into the plans. And, if you know where penetrations are going to be, get those into plans. So we're able to execute on site when we're constructing this home, and make sure things are ready out there for future solar, and we're getting these things solar ready. Get a solar contractor involved early. This is a requirement for our program, but if you're not participating, I really still highly suggest it. If you're doing a zero energy ready home, they're going to be able to tell you exactly what your house can or cannot do, and help you kind of design that and help you kind of understand how much or how little solar panels you might need, depending on the house that you're designing. And I tell you what, we talk to them all the time. These are good qualified leads for them. Even if you don't follow through as a contractor, your homeowners are going to have a good lead, and these solar contractors are going to have a good lead for future solar on there. So this is a really, really great way. Different programs do have different solar ready metrics. So whatever you're working with, whether it's, code, or whether it's an above code program or a certification, just talk to your rater, talk to your professionals, and they can kind of set you up of what you need to be to make sure that these homes are good and solar ready. And, another last step out here is commissioning and monitoring, right? We want to make sure the house is performing the way we designed and constructed it. We want to do blower door tests. We want to test all these ventilation systems, whether it's your whole house ventilation system or whether, it's your spot ventilation system. You would be surprised how many houses I walk into and none of their bath fans, you can hear them, but they're not sucking anything out. This is the value, another value of hiring, a third party rater or HERS rater out there to come out and do commissioning on all these works. Work with these programs out here. Any of these, certification programs are great. You're going to have a rater come out there and, as a third party, looking over your building. They're going to be looking over your subs and making sure things are installed the way you want them to be installed, and making sure that they're working the way you want them to work. Not only is it going to kind of, verify and make sure all this is working, but it's also going, these programs are great sales tools. And a lot of them, some of them have good money attached to them. I'd be kind of remiss if I didn't talk a little bit about, as we mentioned before, this new 45L energy efficiency new construction tax credit. This is a slide from our friends over at Betterbuilt. They have a really great webinar, I think that we are going to have posted at the end of this. So please go check that out. I'm not going to dive too heavy into this in the details because, we have resources out there that already do, but I wanted to kind of just reiterate that, there's some money out there that are now attached to these certification programs as of last year, beginning of last year, for qualified contractors. If you build and certify an Energy Star home, you can get $2,500 per project on that. That's pretty good. If you take another step further and certify your building zero energy ready, that DOE Zero Energy Ready program that we talked about there, that's $5,000 per house. That's a lot of money, if we're looking at that. And we want to make sure that you and your rater is going to make sure that, you're leveraging that and making sure you're getting these tax credits if that's a program that works for you and something that you want to pursue. There's a lot of ins and outs of what a qualified contractor is. And if you have any questions, feel free to contact me afterwards, and I can kind of walk you through this, or go to that webinar and they're going to explain all that there. But I'm here as a resource if you need to kind of sort the ins and outs of that. But the point is, there's some big money out there for now for going to these certifications. On top of that, if you're a builder out here in Oregon and you're not participating in the EPS program, if you're in that, excuse me, Energy Trust of Oregon territory, wow, I, I think this program is incredible, and the amount of money you can get out there, up to $4,000 per house, is really, really great. And this program and the great people at Energy Trust have done so much in our market here to kind of elevate the energy efficiency and get builders to go. And it's one of the most robust incentive programs, I think, in the country. So you look at this, if you're in the Energy Trust territory, you're building a zero energy home, maybe you can get up to $4,000, and then we have all these a la carte incentives that are out there. Solar ready. You make your home EV ready, make your home solar and storage ready. And then on top of that, if you do net zero, that's another $1,000 on top of that. And if you add any of those tax credit programs on top of that, I mean, we're talking about, there could be $10,000 to $11,000 per house for building to these program specs and participating in them. It's nothing to, ignore, and it's definitely something to keep in mind, and make sure that you are talking to your local rater. If you don't know who that is or not sure is one, let us know. Maybe we can help you, or we can point you in the right direction of someone that's going to be able to help you in your marketplace for that. But just want to point out there is a lot of help out there to be able to fund and leverage these incentives and get these into your buildings. So what's the future? I think it's zero energy ready, really. This is going to be the most cost-effective thing you can do for a builder, and following those steps, reducing that energy use. Efficiency comes first, reducing that consumption and getting these into, kind of your everyday building strategies, and getting homeowners set up for future zero energy ready homes, getting your house prepared, lowering that consumption, having those good envelopes, getting the orientation and the roofs right, making these things are solar ready, and getting, these houses to there. Our codes right now are getting really close, as it is. Oregon has a new code update coming up, that's going to be soon. Washington has one. These are becoming more and more challenging code, and we're getting closer and closer to all these things we're talking about. So, get ahead of those a little bit, leverage these incentives that are out there, get paid to do this stuff before Uncle Sam makes you, right? And so this isn't, pie in the sky stupid stuff. You can build really, conventional zero energy ready homes with following these steps. And I think, that's the future. If you build it, they will come. I think people want these type of houses. Obviously, it's not the most important thing out there for a homeowner that's making, purchasing decisions, but maybe it's something that puts them over the edge, if you're trying to sell your home, that can differentiate yourself, from your competition out there, or, gives them something more to sell. Growing trends, what are we seeing out there? There's a lot of talk about electrification out there. There's a lot of talk about high efficiency heat pumps. And these heat pumps are performing really, really well these days in our cold climate temperature, uh, I think we're in a perfect climate zone out here to, be putting heat pumps and everything. They're high efficiency. They can handle the cold. They're better than they were 5 years ago, and 5 years from now, they're going to be better than what they are today. So start looking into those type of systems, whether you're with a ducted or ductless system. Solar storage. I'm seeing a lot of houses out there these days actually going for storage ready or putting storage on themselves. Definitely a lot of zero energy houses that are choosing to go with storage as well when they're going full zero energy. And if they're zero energy ready homes, I see them doing storage ready, maybe getting a smart panel installed in there, or maybe, getting a different box in there for some utilities. EV ready. We're seeing this in almost every home these days. We're going to see a lot more electric cars in there in the future, and homes are getting set up for, future electric cars, level 2 EV readies, all different levels of EV ready. There's money out there, incentives out there if you're an Energy Trust of Oregon to be doing this. So we're seeing a lot of storage, seeing a lot more solar. We're seeing a lot of heat pumps. We're seeing a lot of EV ready. I started seeing smart panels recently, looking at that span. These are all really cool future homes. And so I had to suggest you look at that, and maybe that makes sense for your building. So let's look at some case studies here of some houses that have, executed and been really successful in that. One of our builders out here, Ichijo USA, they're a production builder, and they are building 100% certified zero energy ready homes. And if we're looking at this, it's a fairly, regular show. We got an R38 in the crawl, an R29 in the walls. We're using a 2x6 intermediate framing, but they're using a flash and bib. So they got a little, 1.5 inches, I think, or maybe 2 inches of closed cell spray foam, and then blowing the rust into the walls. And then putting in, an R60 blown in fiberglass attic insulation, and doing some 0.27 code windows. This is a little bit above code, but not incredibly large above code. They're using a kind of standard drywall air barrier strategy with some rattle can foam sill sealer, and using our, envelope checklist as a way to, make sure that we're executing and make sure we're hitting all the right spots. And they're consistently between 2 to 3 ACH. That's a pretty good blower door score. Being very successful with that, simple kind of process out there. Using high efficiency, heat pumps, moved from gas furnaces to high efficient heat pump, bringing the ducts inside the conditioned space. We're doing the design on that and working with our HVAC contractor who was installing and commissioning them to our specs, following that kind of sequence and getting those mechanical systems in there and get those done right. Using heat pump water heaters in there. This is and doing this on a production sense. This is a very simple, easy, well-designed home that's meeting zero energy ready. And in many cases, putting that solar on, that we're seeing it all the time, and making them zero energy. Another great example is a client of ours, Noise Development, has been doing our zero energy ready program since the beginning of it, I think. Again, a little bit of a different strategy on their on their wall system. R38 simple, bats in a crawl, doing a simple 2x6 with advanced framing, blown and bake it, but using air barrier kind of as their air sealing strategy out there. Getting an R49 standard blown fiberglass in there. Just a little bit above code, basically code, but just a little bit of a step, not a huge thing. And that aero barrier, they're getting consistent on a production level, 1 to 1.5 ACH 50. That's a pretty low blower door score. And you're reaping a lot of benefits from that. And so, that is a strategy that they chose with, and they're doing it on the production scale. They got a little bit of better windows, anywhere from 0.22 to 0.26. Depending on fixed or operable and size, it's all over the place, but we do a weighted area value. So a little bit above code on that, but not much. Very affordable, double pane. They moved to a high efficiency heat pump, doing design, install, commissioning that, bringing all their ducts inside conditioned space. But they're still using, a gas tankless for their water heating at the moment. And so we got to go to a source energy when we're looking at that, and we want to do zero energy ready, and you know, making sure that we're compensating for that small amount of gas that's being used there. But a really, really good example of how to do zero energy ready homes consistently and cost effectively in a production setting. If we want to look at zero energy homes, we talked about this earlier. Here's the Habitat from Humanity community that they built out there in Bend. Again, a little bit of a different shell out there. Using an R15 slab underneath and on the edge. R26 wall, R60 fiberglass in the attic. Their wall system, again, a little bit different than the last two. It's 2x6 advanced framing, blown in cellulose. But they decided, to be doing, an R5 rigid exterior. So they got an inch of rigid exterior to, reduce those thermal bridges. And that's a strategy that really worked from them. And, we've looked at fairly different strategies for them, and they have chosen to do it in some instances and chose to do something else in different instances. And we used value engineering to kind of do that, a little bit nicer windows, 0.24s, a little bit above code, but nothing crazy. They're going with a high efficiency ductless system, which works for their products quite a bit, and then a heat pump water heater. And they were able to make these buildings, zero energy with, a 6.7 kilowatt system on there. So not too bad, pretty small system and a pretty buildable house, to make those zero energy. Another zero energy is Solaire out there in Bend, our partners out there at Solaire. Again, different kind of wall system. R38 in the floors, R30 in the walls, R60 in the attic. A little bit above code. They went with a 2x8 staggered stud. So with a blown in system, a little bit more robust of a wall system. For sure. That's something they wanted to experiment with. The blower door score is 1.8 ACH 50. They went with an exterior air barrier out there, and we're able to test these things early and get those blower door scores really low. That's a really, really nice one. Using code windows, again, ductless heat pumps. Interesting about this one, they ended up going with just a standard electric water heater, 95% in there. They had specific reasons why they had to do that, but they were able to meet zero energy, with a 6 kilowatt system and this strategy. So another way you can go about it, that's fairly simple. Our friends at Greenhammer, I think last year or 2 years ago, finished out an attached housing product that we kind of talked about, how we were looking at zero energy, maybe from a development standpoint or from a set of row houses out there. They did a zero energy community that we were able to certify, and they took a different approach. Was there more very high performance? Anyone that knows that contractor, they're a really good high performance builder, and that's how they build. So their systems out there, they have a conditioned crawl with an R19 or sorry R18 out there, a pretty advanced wall system, a 2x8 wall system with blown cellulose and an inch and a half of mineral wool on the exterior there, and then an R65 in the lid. Pretty reasonable, low blower door scores, exterior, air barrier 1.7. That's pretty good. Especially when we're talking about row houses. Anyone out there that works in row houses knows how hard it is to get low blower door scores in those type of buildings because of that construction of those abiotic or common walls. Triple pane windows, obviously pretty expensive there, but we're getting 0.14s. You get a lot of gains there. Using the Minotaur system, I don't know if you guys are familiar with that, but it's a air source heat pump and an HRV combined into one system. That's really nice, works really well for these smaller type buildings. Not the most impressive performance in the world, but pretty good, air source heat pump, and bringing those ducts inside that conditioned space and going with a heat pump water heater. Sure, these are elevated and more expensive assemblies and pieces of equipment. But if you look at that, they have 12 units and they were able to get those zero energy in a 13 kilowatt system. Like that's pretty impressive. That's pretty small. And so they spent their money on their shell and their systems, and they didn't have to spend all their money on their solar system there. So that is a another really great route to do. But at the end of the day, the gentleman, my colleague Ryan Shanahan, who used to do this webinar before I've done it, he had a builder. We had one of our first zero energy ready builders kind of talk to him about, shout out to Ryan Shanahan, of a kite versus a rocket, where he wanted to build kites and other people are building rockets. They're both going up in the air. And so, a kite maybe is we're doing $100 per square foot house, and a rocket maybe is a $200 per square house. Both could be zero energy, it's depending on which way you want to go and what makes sense for you. And we love rockets. I work on them all the time. And they're really valuable with kind of pulling, everyone forward and taking chances and doing things and spending a lot of money and finding the right clients that want to experiment with them in order for people out there to build these kind of kites and these simple, more cost-effective, zero energy ready homes and zero energy homes. So whatever avenue works for you, there is a way to build kites and get these type of homes into your house. So I appreciate all the time that you guys let me have here today to talk. And I'm going to hand this over to Aubrey, and I know we're going to be answering some questions a little bit down the road here.
Thank you, Mark.
You're welcome.
I'm going to go over some additional resources with you all. The first one is that we would love for you to check out Earth Advantage's on-demand training page. We have a wide variety of training opportunities that are available to you to take anytime at your leisure. Here you will find our 45L tax credit, What You Need to Know course, and the Heat Pump Mastery series that Mark mentioned earlier in today's presentation, among many other helpful courses. You can also visit our website to browse and sign up for live courses. For example, we have an upcoming Practical Solutions to Selecting and Installing Exterior Insulation live webinar on March 7th, which also is probably quite helpful in your zero energy home pursuits. I'd also like to highlight, we can go ahead and progress. Thank you, Mark. One of our most robust and on-demand courses is the SHP online course. This resource will assist you in developing the technical expertise to design and build high-performance homes. You can see the many aspects of this course on the screen, or you can also visit the SHP course page that is linked in this presentation on Earth Advantage's website. And again, we will be sharing this presentation with you after today's webinar. Go ahead and go to that next slide. We would also love to highlight the Zero Coalition, who works to decarbonize Oregon's built environment from an equity-centered perspective. We highly encourage you to visit their website to learn more about the work that they're doing. Our contact information. We thank everyone for attending today's webinar. If you have any questions, feel free to contact us using the information on the screen. If you'd like to stay for our Q&A portion, we're happy to have you, and we're going to go ahead and now transition over that Q&A.